Today I'm Kartin, I'm a co-founder of Aura. So Aura is a protocol that will enable any size of AI model on any blockchain. So today I'm going to mainly talk about how on-chain AI Oracle, OAO functions, and how you can build an AI-powered D-app today with on-chain AI Oracle. So AI has increased exponentially since the GPT moment that we have. And back to 2013, you can only use some really simple CNN neural network to do some object classification. But now, you can generate an image that human cannot identify as even like it's real or not. And even after Sora, you can generate a video that human cannot tell is real or not, right? So AI have become so powerful today. And in Aura, we want to bring this power into the blockchain. Not just one, but all the blockchains. So people have the freedom to choose whatever chain they want. Oh, I see. But the question is how, right? Because we know that running the inference or training on blockchain is so expensive because the architecture of blockchain is like you have the same computation happen on multiple different computers in the same time. And then everybody put down the stamp of approval, say, hey, this transaction is correct, and this transaction is not. And by this mechanism, it means that if you just want to do a one inference on any blockchain, it will be executed by thousands of computers. The cost for that will be like pretty much like too high to be used by any D-app. So we propose a solution on-chain AI Oracle. We can use the Oracle to delegate this computation to some off-chain node to let them do the computation. So it will become affordable, and we need to decide a mechanism to make it become decentralized, and also permissionless and censorship resist. And the most important part is like you can use the on-chain AI Oracle for any size AI model. Currently, we already have the Stable Diffusion and Llama 7B on Ethereum mainnet. And here is the smart contract address, and you can go to aura.io to check out the detail. The workflow for on-chain AI Oracle is really easy and simple to be used. You don't need any SDK. You just need to initiate a smart contract call from your smart contract, send a transaction with the prompt and the model nomination, which model you want to run this prompt with, into the OAO smart contract. It's like how you use channeling. It's like pretty much the similar workflow. And then you send the transaction, the prompt, model nomination into the OAO smart contract. And then OAO smart contract will delegate this transaction into OPML node. That's pretty much Aura node. But part of Aura node is built on OPML. So the workflow will be like, Aura node will execute the inference and then transfer the inference into a Merkle tree, and then do the binary search in the Merkle tree to perform the fraud proof, and then submit the verifier to the smart contract. And then the smart contract can verify the fraud proof and verify the ZK proof in some system, and then send the result back to the transaction initiator. And the whole workflow is really easy and straight line. Everybody can build on it today on Ethereum mainnet. And so OAO is aligned now. You can just simply build it, any product with that. And the backbone technology for the OAO is called OPN now. We have co-authored with Conway and Kathy since like a year ago. And this pretty much uses the optimistic way to run the machine learning. And then the most important part is like the verification happen on chain. But like because like doing the OP way is kind of like the most practical way. It's pretty much the best practice to bring AI model into Ethereum. And but like ZK doesn't matter anymore. But it's not. We still need to use ZK proof on a lot of stuff. The first thing is that once you execute the OPML for the node, for the smart contract, you still want to delegate the result in the future, or delegate the result into a different layer too. So ZKP will perform really important role here. So you can use the ZK Oracle from Aura to generate the storage proof for the OPML. So when the inference need to be performed again, you no longer need to perform OPML. Still, because OPML is cheap, way cheaper than ZKML, but still pricey. It's about $5 to $10 the benchmark now, but it's still like the ZKP for that is like cheaper. And so you can use ZKP to delegate the result. That's the first thing. And this is the performance essential reason why we want to dive into the OPML instead of ZKML. Because back to a year and 18 months ago, we was trying to do research on ZKML. What we find out actually is that ZKML do not scale with the model. So the require of the proving cost will grow exponentially, according to the model size increase. So for example, if you need to prove 1,000 parameter model, and the cost is $10, 10, the unit 10. And then when you prove 2,000 parameter, the cost will be of that won't be 20, it will be 40 because it grows exponentially. But so that's why we need some linear growth cost mechanism to do that. That's the initiation for us to open source the library and let everybody to realize this thing. So that when we can bring when the model size go to billion level of parameter, OPML is the only option. And that in OPI, we just released the second paper yesterday. The OPI, I think, is the best practice for the on-chain AI mechanism. So it's OPI stands for Optimistic Priority Preserve AI on Blockchain. So it's programmatic, practical, and privacy preserved. Because in OPML, the biggest problem is that first, the input is not private. So everybody can send a higher transaction fee, a higher gas fee to front run your transaction. So in some DeFi application, you don't want that to happen. And the second part is instant finalization. The ZKML model normally can instant finalize the resale on blockchain. Although these models are super small, most people won't even use that. But it's still important. So the mechanism for OPI is that you have you want to do the ZK proof in the input layer for the neural network. Because neural network is huge, you have multi-layer for the neural network normally. So you can do the ZK proof on the input layer and ZK proof on the output layer. And the middle part do the OP. And then send the verifier to the Aura node, and they will know your inference is correct in your own privacy trusted node. And then continue the OP inference. And then submit the result back to the blockchain. So by this mechanism, you'll be able to have the privacy preserved and also instant finalization for the OPML. This library we are planning to open source that in the Q3 this year. So because we have done so many work in the past 2 years, so it's the time to build the application. Because OAO is alive on Ethereum mainnet, you can do a lot of stuff with that. The first thing is the AI managed DAO. Although it just looks so pretty much human is not incentivized enough to manage the DAO today. It's really low efficient. And if you use AI to do that, it will be way higher efficient. Imagine that, right? You use AI to manage a compound, so you can accept more different assets in the on-chain to do the pounding. And then if you have the AI to do manage the DAO for make a DAO, you can accept more asset to mint it as stablecoin. And that's the first usage. Have an AI-driven DAO can increase the capital efficiency on the current DeFi protocol drastically. And then the second usage will be the AIGC NFT, I think. The EIP 7007 is embedding a model into an NFT so that every time you do an inference, the inference result itself is the asset on chain. So people can trade it and also sell the NFT and sell the model token. And that comes to the one of the major usage for the why you want the on-chain AI Oracle is that you will be able to perform the model ownership on blockchain today. And that is everybody want a piece of OpenAI obviously, but you cannot really buy it on chain, right? So owning the model is another, provide liquidity to open source model also is another important thing. So yeah. Yeah, thanks. Yeah, please check out aura.io and build with us. It's alive now, you can use it today. Thanks. Sir, what's the question?
I'm a little curious how you deal with sometimes generative models are non-deterministic.
Yeah, good question. In OPML library, currently, the one we open sourced it is used based on CPU, because any AI model run on CPU is deterministic. And we also have in-house version of OPML we will open source soon. That is quantifies the model first. We utilize the library called MLGo to quantify the AI model, so that any model that rolled by Golang will be able to quantify immediately. And then we set up the C, and then the C is if the C is fixed, the model weight is fixed, and yeah, then your output is deterministic. Yeah. Yeah.
Could you, for the OPML algorithm, could you describe more just about like the mechanics at a high level? Like, is it does the user have 7-day?
No, yeah, good question. And actually, OPML right now do not require 7 day, just 2 block. Because like the mechanism essentially what how OP rollout does, because OP rollout is so successful, right? So like the mechanism is pretty much you make the transaction into a Merkle tree, and then do the binary search in the Merkle tree, and then find out what's the difference, right? It's the same thing, but replace the transaction into model inference trace. And then you just take the model inference and cut into multiple pieces and deploy that in different level of the Merkle tree, and then perform the binary research in it. And then once we find out some difference in the bytecode, verify it on blockchain. And that's how it works, yeah.
Thank you.
Are you guys only live on Ethereum mainnet right now?
Yeah, currently, and we have planned to deploy on layer 2, probably in a few months from now.
I'm curious why you guys chose to start with Ethereum mainnet. Why not like higher throughput chains?
Because I don't think it does really matter. Like what really does matter for a chain is like the liquidity. Like why people want to use it, right? Everybody is playing on Ethereum still, like most like transaction, right? So like we want to have that supported first, and also like this layer 2, although they are VVM compatible, but in the opcode level, they're still kind of different, right? For example, ZK Sync, right? You will need to modify some mechanism there, and you want to test, you have enough tests before you deploy that. So different layer 2 have slightly different change, and we don't want that change become a backdoor, a buggy way for people's DF. Yeah. Yes, good. Everybody good? Yeah. Thanks.
Thank you.